Hi everyone, my name is Karim. I work for Nokia as a technology and architecture engineer, and today I'll be talking about a tool called gNMIc that allows you to talk to network devices that speak gNMI. So I'll go through a short introduction where I will try to make the case for gNMI, so to evolve from traditional ways of monitoring networks, configuring networks, towards more modern ones. I will go through the different features of gNMIc and then finish with a demo. So it's no news to anyone that networks are growing in size and complexity. This calls for more data to be collected, and that puts a lot of stress on these traditional monitoring systems that we are using. Higher data definition here means not only more data, but also more precision in the data and more or better timing on when to receive that data. So that puts a lot of stress on the CPUs of our routers. gNMI solves that by reversing the way we collect monitoring data or telemetry. Instead of pull mode, we switch to a push-based mode to allow the routers to decide when and how to send the data that was requested. And then with functionalities or features like closed-loop automation and alerting, we need better ways of delivering that data towards the collectors and towards the management system. We need reliable delivery. And gNMI achieves that using TCP transport, or to be more exact, gRPC transport. So what is gNMI? So gNMI was defined or specified by the OpenConfig organization. The protocol stack looks more or less like this. So it defines 4 different operations. It's defined in protobuf. These operations are RPCs that a client can send towards a device that has gNMI enabled. So the first operation is capabilities. It allows a client to query what kind of capabilities the router supports. You will get the gNMI version that the router exposes, the list of Yang models that the router support, as well as the encodings that the router can use to send back data you requested. Get allows you to query, config, or state from your router using a path, so you can query different objects or multiple objects at the same time. Set allows you to modify that configuration, so you can push new configuration to your routers using the set RPC. Subscribe allows you to kind of get data periodically or on change by subscribing to certain objects that are created on that router. Those objects can be configuration objects or state objects. And gNMI runs on top of gRPC, which is said it already, a client-server RPC framework. So it allows a client and a server to communicate with each other based on a protobuf definition. It runs on top of HTTP2, which allows to send multiple streams at the same time, and they don't block each other, so you can have multiple subscriptions over there. If one subscription has a lot of data, it doesn't block the subscriptions that have less data being sent. Then protobuf and Yang here. So protobuf, like I said, defines the different operations and the messages exchanged by the client and the server. And Yang here allows you to encode the content. So it's not mandatory to use a Yang or a modeling language, so it's not mandated by the gNMI specification, but it's a common thing we see across multiple vendors. All right. Okay, so going a little bit more in detail in the gNMI service definition. So like I said, there are 4 RPCs. You can see the protobuf definition at the bottom over there. So 4 RPCs, capabilities get, set, and subscribe. Each one has a request and a response. The 3 first ones, capabilities get and set, are what we call unary RPCs. So to each request, you will get only 1 response, while the subscribe RPC is a bidirectional streaming RPC, meaning that a client can send multiple requests and expects 1 or more responses. So this allows you, or the subscribe RPC allows you to achieve what we call streaming telemetry using gNMI, while the capabilities get and set are just for your configuration management. Okay, so what is gNMIc to gNMI? So the C there can stand for multiple things. So client, collector, configurator if you want. It used to be client back when it started, but you just see it's shorter, faster to type. So first, it's a command line interface for gNMI. So every RPC has a corresponding command. So you can do gNMIc capabilities, gNMIc get, gNMIc set, and subscribe. It's also a highly available and flexible collector. So using the subscribe RPC, you will be able to collect metrics or data from your router and write them, modify them if you want first, and write them to different outputs. It is written in Go, Golang, or the Go language. And it comes with a wrapper around the auto-generated Go code that looks a little bit better or is easier to use for humans. Right. So gNMIc started within Nokia. It actually started around the pandemic time. I did it to, I guess, learn gNMI myself and be able to teach it to other people or share it with other people. And around last year, this time, Nokia donated it to the OpenConfig Foundation. So it moved to a new repo under the OpenConfig organization. So it moved to a new repo over there. So starting with gNMIc as a CLI. So like I said, there are RPC-related commands, capabilities get, set, and subscribe, but there are also utility commands. So there is a prompt that allows you to have some auto-completion over there. So if you don't know the CLI, you're not familiar with the different commands, the flags prompt can help you auto-complete. If you load your router's Yang model over there, it can even complete your XPaths. There's a diff command that runs 2 gets and compares them. So it tells you what is different between 2 different routers, or between actually 1 router and more routers. And there is a generate command that you feed the Yang model to, and it will generate paths for you. You can search through them to see what's supported, what's not supported. You can also generate configuration payloads that you can populate and push to the routers. There are a few other commands. I didn't list them all over here. So how do we use, or how would you use gNMIc as a CLI? So the first way to configure it is using CLI flags. There are global flags followed by the command and then local flags. So global flags are common to all the commands. Local flags are specific to that one command you wrote. The global flags are usually, or pertain usually to how do you connect to the router? What is the IP address? What are the credentials? Do you want to use TLS? Which certificates do you want to use over there? Do you want to do one-way TLS or two-way TLS? That's what the global flags are for. You can also decide how to print the output returned by the routers. And the local flags will be specific to that command. So for example, here, the address, username, and password, and skip verify are global flags. They tell gNMIc to connect to router 10.0.0.1 with admin as credentials, and skip verify means use TLS, but do not verify the certificate sent by the router. And path is a local flag. It tells to get interfaces or interface management configuration and state that's stored in that router.
Kareem, this is Red. Just a quick question. What are the output options that you can get back? Is that defined only through gNMI, that it will repackage it when it hands it to us? Or is that defined by the device that I'm pulling the data out of?
Output here, you mean the responses coming from the router, right?
Yes, sorry, I'm just following off of your comment. You can pick what your output looks like. So I just wanted to understand.
Yeah, so
this output that I'm getting from gNMI, so it's going to take whatever the response was, like say this management interface that we have here, right? If the device, say that I'm pulling this from, doesn't support XML, can I get gNMIc to give me an XML version of the output? Does that question make sense?
It does make sense. Yes and no.
Okay.
So it depends on the router and depends on how the router sends the data to you. So to take your example, I'll just switch XML to JSON, if you don't mind.
Sure.
If if I get a JSON blob back from the router, with let's say I get an array object with multiple dicts in there, right? I don't know which key or which item is the key in that dictionary, right? So I don't have that information. I need to go look at the Yang model to figure out how to flatten that output. What is basically, so for example here, name is the key in what you see in the screen, right? If you send me this as a JSON blob and name is there together with description, admin state, or something else, whatever is under interface, I don't know that name is the key, right? So Yes, you can, but you would need extra information like the Yang model.
Gotcha. Yeah. Thank you.
I have a question on the flow of information. We talked about leveraging gNMI to migrate from a pull model to a push model, decide on the device when it pushes data and what data it streams. It sounds like we're connecting to each device from a server running gNMIc. So we're making the initial connection from that server and then configuring the device to decide what data gets pushed and when?
It's not configuring the device. So what we do is we establish that connection, TCP, HTTP2, gRPC, and so on, and then we send one of those RPCs. So in case of streaming telemetry, we're sending a subscribe request. That subscribe request will have a list of paths that the client is interested on, as well as how to send that data back. How here means, do I want it periodically? Do I want it on change? Or do I want it just once and then close the connection? So we are not configuring the device. We're just telling the device that this subscription that I just established sent through maybe the interface statistics.
Okay.
So that doesn't get configured on the router, but we just tell the router what to send over this one connection, this one stream. Okay. And then we can do that multiple times. Right? So that was the CLI flags. You can also configure gNMIc using environment variables. So you've seen that I wrote the password on the terminal there. Not recommended. So if you want to hide it, you can put it as an environment variable. And you can do that with almost all the global flags and certain local flags. And you just run the same command, gNMIc get. If you want to go another level where you have persistent configuration that you can reuse maybe in different folders or different locations or in Git repos, you can use the configuration file. So the same global flags can be set over there. And you can just run the command, point it to the config file. It will load it and run your command. You can mix all these three different ways of running a CLI. The CLI flags will take precedence over the environment variables, and the environment variables will take precedence over the config file. That way you can have a more or less generic configuration file that you can change using environment variables or the CLI flags. Right. Okay. So a bit more details on the configuration file. That's the preferred way to configure gNMIc when running in daemon mode. So if you're doing streaming telemetry and you want to run gNMIc as a daemon to collect metrics from different routers and write them to an output, say a TSDB, the configuration file is the preferred way. So the configuration file has those global variables, global flags, sorry, there, as well as different sections that allow you to define multiple targets, how to connect to them. So each target can have different credentials, different TLS certificates, subscriptions, which are what I mentioned earlier, the paths and the mode of the subscription. Mode here means, is it streaming or is it once? And in case of streaming, is it on change or is it sampled? Outputs are where you want to write whatever you collected. So outputs here can be a message queue, can be a TSDB, or simply just writing it to a file. Processors allow you to modify whatever you received from the routers and before writing it to an output. And clustering allows you to combine different gNMICs together so that they're not overloaded or load share the traffic coming from the routers. So yeah, you just run the command that way by pointing it to the config file. Now, moving on to gNMIc as a collector. So a collector is basically connecting here to different targets, receiving gNMI notification or gNMI subscribe responses. It will go and write them to different outputs. So the typical output you see is a database, typically a TSDB. The usual suspects are InfluxDB and Prometheus, or whatever flavor of Prometheus. So gNMIc allows you to do that. You can, let's say, customize how you write to InfluxDB and Prometheus. You can cache the data and write it periodically, or just write it as it comes. You can write to a message queue. So both NATS and Kafka are supported here. So the two flavors of NATS are supported. So NATS and NATS streaming. Or you can just write it to a terminal and a
just
file.
something there on, so Lindsay Hill, just something on the targets I'm thinking about. How does it, let's say I've got my configuration file, and so, these are the 100 devices that I want you to collect data from, getting interface stats every minute and BGP changes, whatever, that sort of stuff. It's all good. Does it handle things like what error handling and retries and things? Because, obviously in an ideal world, all of my devices are reachable, but,
Yeah, they're not.
it's a complicated place.
Yeah.
Does it, what happens when this device is offline at the moment?
All
Can
right.
it handle that sort of retry and those, and, because one of the problems obviously with streaming stuff is, well, what if the problem's the device is not sending anything? I'm waiting for it to tell me a change, but it can't tell me the change because it's got some other product problems. Just
Sure.
can you talk about some of that error handling and those sorts of
All right. Yeah. Good question. So it depends where the error is, right? It depends where it is on that protocol stack. If the device is not reachable, gNMIc will just keep retrying. There is a retry timer. It will literally retry forever, right? Until
probably put something in a log or something.
Yes, it will print it in the log saying fail to connect, retrying in 10 seconds. 10 seconds is the default value. 10 seconds after, it will try again. That's TCP or your HTTP2 or gRPC connection. If the error is on the device, I don't know, is stuck, received the subscription, acknowledged over HTTP2, but is not sending anything. Most devices, or the devices I work with at least, allow you to monitor the subscriptions you created. So the subscriptions you create get their own state. You will know which client connected. You can have a user agent name that you configure in gNMIc, and you will see that this is gNMIc 1, 2, 3, or 4 that connected. It requested for these paths on change. And some devices will also tell you, in the past 1 minute, we sent 100 messages. And then you compare, did I actually receive 100 messages? And one of our routers, SROS, will also tell you that I tried to send, but I failed because XYZ. So you should monitor yourself. Maybe a little bit meta, but you should monitor what you're monitoring. But yeah.
Monitor your monitoring.
Yeah.
I know, but
So
it's a problem sometimes. Yeah,
it is.
Like we have, for our own monitoring, we have like layers of monitoring as well, right?
Yeah.
And you can't catch everything, but maybe sometimes I can catch when the monitoring system has a problem monitoring the thing. Yeah.
So talking about that, monitoring yourself, gNMIc also exposes an endpoint that Prometheus can scrape. So it exposes its own internal metrics. It's not just metrics about the router. It exposes how much memory it's using, how much CPU, how many threads are running, how many subscribe responses were received from which router in the past, I don't know, window of time. And you can compare that to what you're getting from the router, what you're expecting, and what you're seeing in your message queue or in your TSDB. And that way, you'll figure out.
We use Prometheus for monitoring a lot of server-related things. We also have some things that kind of look like Prometheus, which then go and grab data from network devices. But yes, and for some of this interesting stuff there is things like, how long did it take device to respond? What sort of, and the other stats you're talking about, how many things are you getting out of these devices? That's that's all quite useful stuff to know, because I have widely distributed systems, and some of them are busy systems, some of them are a long way away, some of them take a long time to respond. That's normal for that device, but you want to see what happens over time with that.
You can even calculate the delay between when the router sent the message and when you received it.
The timestamps.
The timestamp is part of the message. That's actually one of the main advantages of gNMI over things like SNMP. The timestamp comes from the router; it doesn't come from the collector. So talk about fine-grained data.
Yeah, because I have problems with some metrics where, you're trying to get to too narrow a window, and your polling cycle, and trying to take into account the polling cycle versus the measurement window, and it gets
tricky.
Yeah,
it gets tricky. Right.
That's good.
So I had a quick follow-up question to that. This is Nick Ramalio. So Lindsay mentioned, things are out and far away, and I apologize if I missed it. But you've got Nokia has a suite of different platforms. Is this available across your SR series as well as the SR Linux-based devices? Can I run this on a 7750 running SROS?
Can you define this?
And export my.
gNMI.
I'm sorry. Can I use this streaming telemetry model that you're describing across all of your platforms?
Oh yeah, sure. Yeah, both routers support gNMI. You can use gNMIc or any other client. The only difference there would be that you're dealing with different Yang models, so your paths will be different. That's basically it. Yep.
Yeah. I think that is an important one. Yeah, like that SROS versus SR Linux, and yeah, the support's there on both of those.
Yeah. Right. Okay. So you did mention that, say that in your file you have 100 routers, right, or 100 targets defined. Nobody will be going and writing 100 different routers manually in a file. So gNMIc allows you to dynamically discover your routers. It does that using what is called a loader. So the loader can simply be a file that's auto-generated, and gNMIc will just go and read it periodically, do a diff. These are the targets I know. This is what's in the file, what's new, what's gone. We'll disconnect. If it's gone, we'll create the subscription. If it's added.
Sort of along the lines of what some of the Prometheus collectors do.
Correct.
Like so, obviously there's some of the same design thinking there, and it's good. That's good.
Yeah. That's exactly it. And I'm coming to, so in Prometheus it's called service discovery. And you can do that through an HTTP server. You can query an API, something like Netbox, for example, where you have your whole inventory and connect to all your routers. Or you can register your routers as services in console. So whenever the service is created, gNMIc will get notified immediately, connect to that router or create the subscriptions. If the service is gone, it will just disconnect, just like Prometheus does. And the last one is Docker. So if your routers are running as Docker containers, like you've seen in the previous talk, this was actually only added for Container Lab. So gNMIc can discover routers running as containers dynamically, create the subscriptions. If they're gone, it will just delete it. So like I said, gNMIc will just connect, and once it receives notification, we'll write them to any output defined. So when you're, go ahead.
I had a question, because if you could go back to the last
Sure.
slide. So Micheline Murphy, you talked about the dynamic discovery. Does it work the other way, that you have, you've got some kind of document that says, I should have these devices, and push that compliance down to the network so that it'll prune out devices that you don't have on your whatever source of truth? Does it work the other way? Can you say, I need my
Which source of truth do you trust?
Yeah, that's, I guess that's
Yeah.
We have lots.
I'm like,
So say you have a list of routers,
Yeah.
right? Say in a file.
sure.
You can use this, and if you see something in the log that says like device not reachable, then it's not there. But
Yeah, I mean, I get the whole, stare and glare and try to, like, me personally figure out what's in my environment versus what's on my file.
Yeah.
What I'm asking is, do you have the capability of saying, okay, this is what my network should look like. It should have 5 devices.
Yeah.
It goes in, it looks to see if it's got the 5 devices, and it prunes the 6.
you can do that, but that was not the intent of this loader. So what you can do is this. You can define that in a file, like you said. gNMIc will try to connect to all the routers that are defined in that file.
Mm-hmm.
If one is missing, it will either be reflected in the logs, if that's good enough for you, or you can expose gNMIc internal metrics that tell you, I'm connected to 5 targets.
Okay.
If you're expecting 6, then one of them is missing.
Okay.
All right. So when you're collecting data, you want to process it, or you want to manipulate it, because the router is maybe not sending what you're expecting. It's sending up lowercase. You want it lowercase. It's sending up as a string, but you want it to be a 1 because you want to write it into Prometheus, which only takes floats. So there are processors in gNMIc that allow you to do that. So you can do type conversions or just string replacements if you want. You can enrich messages. You can even create new messages. A nice example I like to talk about often is there is someone using gNMIc to just create an inventory of the gbix on their routers. There is no specific metric or no configuration or no state that says it's this SFP from this vendor with this model, this serial number. So you can query it, but it comes with the interface configuration. So what they did is creating a processor that takes all that data, creates a completely new metric, and then writes it into a database. So that way you have a full inventory of whatever SFPs are in your network.
We do something like that with some of our server side of things where, with this data we want to collect from them and put into Prometheus, but there's no, like, it's not like a counter or something, instead it's like the service tag for the server, right? And so we have some things we do to store that somewhere and then basically pull that. And it's, and stuff like collecting serial numbers for optics, like it sounds quite dull, to be honest, but in reality, it's actually really useful to know what your serial numbers are and to be able to track those changes.
Exactly.
Because sometimes I've got faulty optics in remote sites or whatever. I need to get remote hands to swap them out. I need to make sure that faulty optic doesn't come back in. So I do actually need to track those serial numbers. So,
it's a great example. Like, I really like it. All right. You can also do filtering, allow deny list. Some routers will send you more than you need. Drop it. And you can trigger actions, closed loop automation. You can trigger another gNMI request. You can take whatever you received using a template, convert it to another completely different format, send it to an HTTP server or to a REST API, or you can just run a local script.
Rather than, like, normally I would think of this in terms of, I'm going to collect my data, I'm going to put that in something else. Let's say put it in Prometheus, and then I'm going to let Alert Manager or something look at Prometheus and do stuff with it. But if I wanted to, I could sort of shorten.
Make your loop smaller.
If I wanted to.
Make your loop smaller if you want. You don't need to store it.
I probably wouldn't, but then again, it's probably a reason you would as well.
Go ahead.
I was just going to ask real fast on processors. Do you have any number of like example or commonly used processors that are loaded by default with gNMIc?
So there is nothing loaded by default. You can just run it without using any processors. It really depends on your case. The way you do it is like you've seen the configuration file. You just list literally everything, and then you map them to each other. I think I have it here. You define your processors somewhere in the file, and then you say for output 1, run processor 1, then processor 2. So they're defined once, and then you just map them to outputs. So there's nothing that happens by default. Really, every router is different. Every need or every person or every network admin needs are different. So they're not there by default.
Question. Snehal Patel. For large number of network devices, how do you scale gNMIc?
I think I have there you go. Next one. Perfect timing. Great timing. So the way you scale it is by creating a cluster. Right. So it allows you to have, like you said, scale, high availability, and that cluster will redistribute the targets between the different instances. So this cluster is based on top of either console or Kubernetes. So it will use console service registration and service discovery, or it will use Kubernetes leases to register. So each instance registers itself so that the others can find it, and they just communicate via a REST API that gNMIc exposes.
Right. So, thank you, Karen. So in this clustering model, you are dedicating a specific gNMIc instance to a specific device. Are there situations where you can have multiple gNMIc instances taking a stream from a single device?
You can do that.
Parallelize a workload?
Yeah.
And then when you do that, how do you sort of maintain consistency with the sort of time aspect of returns?
So what you can do is have more than one gNMIc connected to your routers, collecting the same data, and only one of those gNMICs will write to the output. So they will basically compete for a lock. If instance 1 gets the lock, it will write to the output. When it loses it, instance 2 will acquire that lock and start writing to the output. So there is a way to do that with only the Prometheus output, actually. So gNMICs will not register themselves into console so that Prometheus, so that Prometheus does not see them. Only one of them registers. So the demo will basically be deploying this topology. So two pods, 4 leaves, 2 spines each, and then the 2 pods are connected using 2 super spines. I will use gNMIc wrapped in a simple bash script to just configure the point-to-point interfaces, the loopbacks, the BGP neighbors, the BGP ASs, and then make sure that everything is configured correctly. So I have a script to deploy the topology. So it's using Container Lab that you've seen in the previous session. So it's deploying 14 SR Linuxes, 8 leaves, 4 spines, and 2 super spines.
Are we going to be able to get this topology?
Yep. I'll push it to that repo you see there, the path,
okay.
Right after the session. So it's deployed. I'll connect to the first spine. Show interfaces. So you'll see that there are 6 interfaces that are not configured. I'll run my configure script pointed to spine 1. Run that show interface. Now each interface has an IP address. There is also a new network instance called default. It has a router ID. And if I show the BGP neighbors over there, I can see that there are 6 neighbors in state active. The connection is not established yet. If I run the same script and don't specify any target, it will just configure all of them. And in a few seconds here, so it's trying to connect. First one is established. And in about maybe 10 seconds, I would say. So you can see here that all the neighbors are established, and there are some routes shared or exchanged over here. Right. I can also do checks using gNMIc. So this runs or shows checks the BGP state on all the routers. Sorry, calculates how many neighbors are there and prints their state. So you can see that they're all up right now. So I'm done configuring my topology of 14 routers in about 20 seconds, 30 seconds, right? Okay. And you've seen a streaming telemetry demo, again, in the previous session. I'll show you the Postman version of that. So this is a new feature of gNMIc that's not released yet. So I wanted to make it for this session, but I wasn't able to push it. But what this shows is, so running gNMIc, again, as a collector. So I pointed it to that configuration file that looks,
So you could use this in an instance where you had like a gNMIc collector running in your normal infrastructure, but for some reason you needed or wanted to pull data live directly to you.
Yep.
Or if, for instance, you're in a location and you're trying to get something off the ground and it's not connected or not able to reach your other collectors like in your normal infrastructure, you could still get the same data that you would expect using the same tool that you would expect and try to figure out what you need to modify in your monitoring that's monitoring your monitoring to fix that.
Correct.
Gotcha.
Yep.
Cool.
All right. So this is the configuration file that I use to print out this ASCII graph. So I define my target. So it's spine 1. I define my subscription. So it's looking at in and out octets from interface Ethernet 1.3. And it's writing it to this output called, or of type ASCII graph. And there is a processor here. It's a Starlark processor, which is, so Starlark is a flavor of Python. It just takes the in and out octet counters and then calculates the rate out of them. So if I show that interface Ethernet 1.3, I can see that it has 111 as an IP address. The other side is 1110, so I'll ping that. in network instance default, I will give it a size of 1,000. And you can see that the rate will increase in the graph above.
When are you going to push that?
You will need this version of gNMIc that I haven't pushed yet or haven't released yet, so it might take a week or two. Yeah. So if you liked it, looks interesting, go to the documentation webpage, so gNMIc.openconfig.net. There are examples, deployment examples over there. There are configuration file examples and short guidelines on how to connect to different routers. So yeah, and then if you have an idea, you see a feature or something is broken, open an issue on the GitHub repo. We will answer. And give the repo star and grab a gNMIc sticker from over there.
We all hope that streaming telemetry will be like the new wonderful thing, the savior, and SNMP will be die, whatever. But like the reality is, SNMP will be around for certain things for a long time. I mean, there's certain things where it's perfectly fine for what it does. Streaming telemetry has advantages, and that's great. One of the challenges has been that the tooling has not quite been there. Like just there's pieces are there, but like in terms of if I'm a busy network admin, I can go and install LibreNMS or something like that. I can install that today, and that will be good enough for covering a lot of what you need. It won't cover everything, but I was just gonna say it's the tooling like this that really matters for making streaming telemetry real and really usable for people. So I just want to say appreciate what Nokia is doing. It's good work.
Thank you.